Hi fellow viewers, we are again going to tackle a question that was done on July series 2023 survey 1 for diploma in building, diploma in civil and diploma in architect. We had there a question of 8 marks. This question, according to me, was supposed to be given to the second years, but because it's found on leveling, where we consider the surface of the earth as spherical, that is the geodetic surveying, this question kind of is right for the first year students, so make sure you revise on the same. But much of this will be done on curves for module 2. Let's go ahead and we see the question. Using a suitable sketch, show the curvature of the earth is given by, so we have been given there an equation, d squared over 2r. So we need to prove that the curvature of earth is equals to d squared over 2r, where d is equals to the measured distance and r is equals to the radius of the earth. A total of 8 marks. So this was a wonderful question to be set for the learners, at least to know something. So you have been theoretically saying the earth is spherical, but here is how we can prove that is right. From the formula of curvature correction, we can derive the following. Let's go ahead. I will illustrate the diagram there, you can observe. So let AB, that is distance AB, is equals to D that we have been given there, the D, the measured distance. So that is the horizontal distance in either in kilometers, because earth is big. So D is equals to the horizontal distance in kilometers. And then on our diagram, B, D, we can observe B to D, that is equals to the curvature correction, that is C, curvature correction. And then distance D, distance DC, which is the same as the distance AC observed there in our diagram, that is the radius of the earth. So DC is the same as AC, that is the radius of the earth given as R. Then D to D prime, that is the diameter. So from the circle, so from the edges of the circle, that is the diameter of our circle. From the properties of a right angled triangle, so I have formed the right angled triangle. You can see from the diagram there the distance BA, that is the horizontal line. And then we have the level line there, that is the curvature of the earth. That's why we have our level line. So from triangle ABC, as observed there, that is a right angle triangle, because when you drop tangent length, that is tangent length provides 90 degrees to radius of a circle. So any distance that is subtended from the center of the circle to the edges of the circle, when we drop the tangent length, that becomes 90. So tangent length in collaboration with the radius, we get the 90. So from the right angle triangle, we can use a simplified formula. This formula was found in high school for trigonometry equations. We can use either side. So let me use my hypotenuse as the longest side, so BC. The square root of AC plus so that is the addition of the square root of AC and AB will give me the answer that will provide is the value of the square root of the hypotenuse. So that means BC squared is the same as AC squared plus AB squared. So that is just as simple as that. So because the opposite and the adjacent squared, our answer, the square root of that will give us the hypotenuse. Let's go ahead. So in the distance BC, we have added, so BC that will be R plus the curvature correction, that is CC, that is the distance that we have been given there. So CC, that is the distance, so R plus CC squared is equals to AC is also a radius, so there we change and that becomes an R. Then AB, we had said AB is equals to the horizontal distance, so that is D squared. We can observe there BC, that is the distance BC, that is R plus CC, so we square that, is equals to R squared plus D squared. When you go again to the mathematical equation, that is the quadratic equation and expressions, you can look at that. So that is found in that is year 3 of secondary and high school education. So R plus CC squared will be R plus CC into bracket multiplied by R plus CC, getting our answer as R squared plus 2 RCC plus CC squared is equals to R squared plus D squared. After doing that, we come again. So CC squared is neglected because it is a very smaller value in comparison to the diameter of the earth, so we remove that CC squared. Our equation we are left with R squared, which when it shifts to the other side it becomes a subtraction and our answer becomes there as 0. After that we remain with 2 RCC is equals to D squared. And again, if we want to, so that is a multiplication, in order for us to get our answer, so CC will be equal to, we move the 2 radius to the other side, so it becomes a division, and that our final equation for the curvature is equals to D squared over 2R. Yeah, that will be all. Revise and you will get more that. So that is the correct substitution of the equation. Thank you.